Students, now we see the topic electrochemistry session 7. Before the topic, you will subscribe the channel and press the bell button for notification. Thank you. Next, the main objectives of this session 7 is about batteries, Lagrange cell and the Mercury button cell. So one by one we will see that. Now first batteries. What are batteries? You know very well. Batteries are indispensable in the modern electronic world. Indispensable in the modern electronic world. That is reused for a long time. That is the batteries. Okay. Now, for example, lithium-ion batteries. Lithium-ion batteries mean inside the mobile we have the lithium-ion batteries. And then dry cell. Dry cell is a flashlight cell. Dry cell we have used the torch lights and then wall clocks and then torches. They are the dry batteries. These batteries are used to the source of direct current at a constant voltage. Constant voltage. They gives a constant voltage in long time. Okay. Next we can classification. Classification is very important for batteries. Primary batteries and secondary batteries. Primary batteries means non-rechargeable. Non-rechargeable batteries are the primary batteries. Secondary batteries are rechargeable. Rechargeable secondary batteries. Okay. Now the main classifications are the two types. Now we see the electrochemistry of some batteries. One by one we will see that. This is the dry cells. Dry cells are used in various voltages we have. Okay. We used in regular life. Next one, in mobile cell phones we have used lithium ion battery. This is the lithium ion battery. Now Lagrange cell. Lagrange cell is one of the important example is dry cell battery. Dry cell battery we used regularly in our life. Okay. Dry cell batteries inside one black color electrode is there, that is called carbon cathode. Inside you break the battery and take the inside materials. One is the electrode, very important electrode, carbon electrode, cathode. Okay. Next the black powder, that is carbon and manganese dioxide mixture. That is the mixture of inside the battery. This is very important, manganese dioxide and carbon mixture. Okay. Now outer layer is there, that is zinc anode. Okay. Zinc anode. Inside one is a carbon manganese powder, and then separator is there. Separator after the powder, manganese dioxide powder, the electrolyte paste is there. Electrolyte paste means ammonium hydroxide, ammonium chloride, any one of the electrolyte. Okay. Electrolyte paste is there because this is the medium for the electrodes. So this is the parts. Function is this is positive, this is negative. The electrons from cathode to anode. The flow of electron is cathode to anode. The bulb is connected. Now electrons moving from the center electrode, that is graphite electrode. The electron move from negative to positive. So This is the principle for the dry cell batteries. Next description for the dry cell is Lagrange cell. Anode is zinc container, cathode is graphite rod in contact with manganese dioxide powdered mixed with graphite rod. Already you know very well, dry cell, inside the dry cell is there. Electrolyte is ammonium chloride and zinc chloride mixed with water, mixed in water. This is the combination of ammonium chloride and zinc chloride. EMF is 1.5 volt. You know very well, pencil cell or torchlight cell, the capacity is 1.5 volt. Cell reaction, zinc is reduced, oxidation in anode, they lost the electron and changes to zinc ion, zinc 2 plus ion, okay, 2 electron lost. Next, reduction of cathode, ammonium ion, ammonium already says that ammonium chloride is there, ammonium ion absorbed the 2 electrons and changes to ammonia and hydrogen gas, Now the hydrogen gas, how is the hydrogen gas is reduced? Hydrogen gas is react with manganese dioxide. Manganese dioxide gives Mn2O3. Mn2O3 it changes another compound and H2O. So this is the additional reaction because we reduce the hydrogen gas. Okay. Next, whole reaction is the zinc ion, zinc metal and then ammonium ion and then manganese dioxide gives zinc ion, changes to zinc ion because loss of electron, and then Mn2O3 and then H2O and then ammonia. Ammonia is produced in the cathode, combines with Zn2 plus to form complex ion, so ammonium zincate complex ion. The ammonia is already evolved in this reaction. Ammonia react with zinc ion, Zn2 plus. As the reaction proceeds, the concentration of ammonium ion will decrease and aqueous ammonia will increase, leads to decrease in the EMF of the cell. This is the reason for dry cells weakness for days gone because of reducing ammonium ion and increasing ammonia. This is the reason for this. This is a very, very important one point in NEET exams also. Okay. Next, mercury button cell. Mercury button cell is we have used in watches and calculators and CPU inside. The button cell is used. This is the button cell type, image of the button cell. In this button cell, the outer steel case, steel outer top means top of the cell, okay, and then tin plated inner top. Inside the top, the tin plated is there, okay. This is another layer. Next, gasket is there. Gasket means this is the insulation material. You see the battery, the insulation is there in the gap. Okay. Next, zinc anode. Zinc is the anode, acting as a anode. This is very, very important. Zinc is acting as a anode. Next, electrolyte. Electrolyte is potassium hydroxide and zinc oxide. Potassium hydroxide and zinc oxide. This is the electrolyte. Next, cathode. Cathode is mercury oxide, HgO and graphite with graphite. Next, inner steel case, the gas gasket. I already told that the gasket is there, the gasket and then barrier. This is the barrier, gasket. Next, gasket to next, the barrier is there, barrier. Okay, this is the image. Next, the description of the mercury cell, mercury button cell. Anode is a zinc amalgamated with mercury. the zinc already in image the anode is zinc. The zinc is amalgamated with mercury. Next cathode. Cathode is a mercury oxide mixed with graphite. Graphite rod is there. Next electrolyte paste of potassium hydroxide and ZNO. Potassium hydroxide and zinc oxide. Oxidation occurs. Oxidation Z0 oxidation state, that is metal. Metal loses the electron, it reduces losses 2 plus, it changes to 2 plus. Zinc oxide, it changes to zinc oxide 2 plus, oxidation state 2 plus, because loss of 2 electron. That 2 electron is absorbed to 2 hydrogen hydroxide ion changes to H2O and 2 electron is there. This 2 electron is moved to cathode. Cathode is mercury oxide plus 2 state. It is oxidation state is plus 2. Plus 2 is changes to 0 because the 2 electron absorbed from the anode. Understand? And water is there. Water, the Hg metal changes to mercury and then 2 hydroxide ion is evolved. The overall reaction, zinc and HgO, zinc and mercury oxide, zinc oxide, it changes to zinc oxide and mercury, zinc oxide to mercury. The whole voltage EMF of the cell is 1.35 volt. Uses the higher capacity, longer life. You know very well the pacemaker, electronic watches and cameras. Pacemaker means heart, inside the heart operation, due to at the time of operation, heart operation, the pacemakers. Okay, pacemakers and then electronic watches and cameras. Next session, the secondary batteries like lead storage battery and lithium ion battery and then fuel cell. We will see the next topic. Okay.